Let's talk about infinite limits. Consider the function f of x equals 1 over x, whose sketch I've given here. What happens to the function as x approaches 0? Well, we notice as we approach 0 from the left, our function goes down towards negative infinity. And we also notice that as we approach 0 from the right, our function goes to positive infinity. Therefore, what can be said about the limit as x approaches 0? Well, as always with two-sided limits, we look to see if the left and the right side limits are equal to one another. Here, negative infinity is clearly not equal to positive infinity, and therefore our two-sided limit as x approaches 0 does not exist. Keep in mind here that our use of infinity, whether plus or minus, does not imply that that's a number. It's only just a symbol that represents some relatively large sum. While it's true we could have said both the left and right side limits did not exist, knowing that a limit does not exist versus knowing what each side of the function tends towards is drastically different information. And the latter clearly gives more information, and that's why we use it. Now imagine instead we were looking at the function 1 over x squared. What we notice is that as we approach 0, whether it's from the left or the right, our function is tending towards positive infinity. Therefore, we'd say the limit of our function as x approaches 0 is positive infinity. And while it's true this limit does not exist, we use positive infinity to give us more information about the graph. By saying the limit doesn't exist, you don't really have an idea of what's going on with the function, but by saying the limit is positive infinity, we know that both sides of my function push upward towards positive infinity.